Pre-statistics. Function notation. Lesson objectives. Use function notation. Find inputs and outputs of a function. Lesson objective. Function notation. To use f as a name of a linear function, y equals 2x plus 1, we use f of x to represent y. We refer to f of x as function notation. To use function notation to write the equation of this function, we substitute f of x for y in the equation y equals 2x plus 1. So this is telling us our independent variable is x, and f of x is our dependent variable. And whenever you see this, you can just look at the equation and know that it's a function. Evaluating a function. Example 1. Evaluate f of x equals negative 4x plus 2 at 5. So we begin with our equation. We want to know what is the y value when x is 5, so we substitute 5 in the equation everywhere we see an x. Then following the order of operation, we multiply and then we add 2. We get negative 18. So we would say f of 5 equals negative 18. Now as an order pair, when x is 5, the dependent variable is negative 18. Example 2. For f of x equals 2x squared minus 3x, g of x equals 4x minus 2 divided by the quantity 5x minus 1, and h of x equals 3x minus 5. Find the following. Number 1, f of negative 2. So we are going to substitute a negative 2 everywhere we see an x and evaluate it. G of 3 means everywhere we see, for this function, everywhere we see a x, we're going to substitute a 3. Number 3, h of a, so everywhere we see a x in this function, we're going to substitute an a. And then h of a plus 2, everywhere we see an x, we're going to substitute a plus 2. So number 1, f of negative 2. So following the order of operation, we have to compute powers before we multiply. So negative 2 squared becomes 4. Now we multiply. So we get 8 plus 6, which is 14. So f of negative 2 equals 14. Number 2, g of 3. Everywhere we see an x, we substitute in a 3. We have to evaluate this expression and this expression before we divide. So we have 12 minus 2, which is 10, over 14. And of course we need to reduce, and we get 5/7. So g of 3 equals 5/7. Number 3, h of a. Everywhere we see an x, we substitute an a. So we're left with 3a minus 5. There's no like terms, so we are finished. And number 4, everywhere we see an x, we substitute a plus 2. So now we can use the distributive property here. So we're left with 3a minus 6 minus 5. Combine like terms, and we're left with 3a minus 11. Here's a visual of what's called a function machine. We have f of x equals 0.012x squared minus 0.19x plus 8.7. We want to put 30 into the function machine. The function will take an input of 30 and put an output of 13.8. So a function machine, you put in an input and it's going to spit out an output. So let's look a little bit more in depth in this example. So we have our original function. We're going to input 30. So everywhere we see an x, we substitute a 30. Now we follow the order of operation. We have to square first, and 30 times 30 is 900. Then we multiply, Next we subtract and add, and we get 13.8. So f of 30 equals 13.8. If we were to write this as an order pair, when x is 30, the function is 13.8. We can use the TI-83 or 84 to evaluate functions. So let's do this example. We need to put in the function into our graphing calculator. So we go to the y equals. We type the function negative 0.016 x squared plus 0.93x plus 8.5. Enter. Now we have the function into y1. So we want to evaluate it for different values. First one being -1. So our next step is to go back to the home screen. So we hit second in mode, which is quit. We want to go to the vars key, that's short for variables. We want to go to the y vars. We want it function, so we hit enter. We want y1, so we hit enter again. And this time when we hit parentheses, put in our input -1, close our parentheses, hit enter, and the TI-84 calculator determined the output when the input's -1. Now for 0, we can hit vars, y vars, enter, enter, parentheses. This time we want to use a 0. Close the parentheses, hit enter, and we get 8.5. To evaluate when x is 4, we could go to vars, but here's a shortcut. If we hit second and enter, this is sort of like a copy and a paste. This brings up the last thing I typed in, so the only thing that we need to do now is change this 0 to a 4. Hit enter. That's our value when x is 4. And I'm going to use that trick again. Second and enter. Change the 4 to a 10. Close the parentheses. Hit enter. And then that is our output when the input is 10. So using the graphing calculator is useful if you have to evaluate the same function for multiple values of x. Lesson objective. Example 3. Let f of x be equal to 3/2 times x minus 1. Number 1, find f of 4. Number 2, find x when f of x equals -4. Number 1, everywhere we see an x, we substitute a 4. So we get 3/2 times 4 minus 1. That becomes 6 minus 1, which is 5. So f of 4 equals 5. Number 2, f of x is the same thing as y, so we want to find the x when y is equal to -4. So we substitute -4 in for our y. There's different ways of solving this. I'm going to get rid of the fraction by multiplying every single term by the denominator. That will eliminate the fractions. So 2 times -4 equals 2 times 3/2x minus 2 times 1. These two will cancel. So this will be 3x minus 2. And of course this will be -8. Now we add 2 to both sides. And we get -6 equals 3x. Dividing by 3, x is -2. So when x is -2, f of x equals -4. Let's look at a table. A. Explain why the table defines a function. Well, if we look at the inputs, the x, all the x's are different. So therefore, each x has one and only one y. so it's a function. B, find the domain and range of this function. So if you recall, the domain is the x values. So the domain are the values here, 0, 1, 2, 3, and 4. And the range is the dependent variable. And we have 0, 1, 2, and 3. We don't have to copy the 3 down twice. C, what is g of 1? So what this means is when x is 1, what is the value of g of x? And that is 0. D, g of 3. When x is 3, what is the value of our dependent variable? That is 2. In part E, find an x such that g of x equals 3. So now my g of x is my y value. So I want to know what is the x when y is 3. So we have a 3 here and 1 here. So this has two answers. When x equals 0 and when x equals 4. Thanks for watching.